Good evening, students. Today we are going to learn about the important topic called Pythagoras Theorem. But before going to the Pythagoras Theorem, we shall understand the included concept called ratio of area of two similar triangles, and the two similar triangles formed by joining vertex or right vertex of a right angle triangle to the hypotenuse. I mean, drawing a perpendicular from the vertex of a right angle triangle to their hypotenuse, then two similar triangles are formed. So how they are similar? Those things. So first we shall start with the condition or the concept that if we have a right angle triangle, consider this right angle triangle as ABC, where angle B I am taking as 90 degree, means the triangle is right angled at B. Here AC is acting as hypotenuse, and we have to draw the perpendicular from B over the hypotenuse AC. So for drawing the perpendicular, we have to start from the B and make a perpendicular on AC, means 90 degree at any point. Let us consider this is the point P. So BP is perpendicular over AC. What does it mean? It means the angle BPC is 90 degree. The angle BPA is also 90 degree. So the theorem or the important concept is like this. If a perpendicular is drawn from the right vertex of a triangle over the hypotenuse, then the two smaller triangles formed are similar to each other, and as well as these two are similar to the original triangle. Means our original triangle here is triangle ABC. This is the original triangle. If we draw the perpendicular BP over the hypotenuse AC, then the two triangles formed are triangle ABP, or you may write triangle APB, mean the same thing. The other right angle triangle form is triangle CBP. So these are the three triangles. So these two new triangles which are formed, these two will be similar to the original triangle, and they will also similar to each other. This we have to prove. So student, the theorem is like this. If a perpendicular is drawn from vertex of right angle of a triangle to the hypotenuse, then the triangle on both sides of the perpendicular are similar to the whole triangle to each other, mean the same thing. Means the original triangle ABC, the two triangle formed on two sides of this two part of this hypotenuse, triangle APB and triangle CPB. So these two triangle APB will similar to triangle CPB, and they will also similar to triangle ABC. These three triangles are similar to each other. So these are the two triangles which are formed. Then triangle ABC, means the original triangle, is similar to the two new triangle APB or ABP. This will also similar to the other triangle CPB or CBP. So what are the two new triangles formed? So I may consider initially the entire original triangle. This is the original triangle. The two triangles which are being formed by drawing the perpendicular BP. So we will focus over only one at a time. Later on we can prove for the other in similar fashion. Let us consider the new triangle BPC. You may also consider triangle BPA. For ease of understanding, I am taking this bottom one. So this triangle I am considering. So these are the two triangles that I am going to consider. So for proving this similar, we need to adjust this given condition in term of either AA or SAS or SSS. Here we are getting that SSS doesn't appear as good. Now coming to the AA, it is already given that perpendicular means 90 degrees known to us. If we are able to prove one of the other angle equal to the other, then A will be satisfied. So that we have to try. A student, so let us continue. For that, let me redraw this triangle for explaining a bit more. So be careful. I'm going to explain a bit more the same thing, but in a different diagram. Let us draw the triangle again. This is only for explanation. Later on, I will erase it. The same name, ABC. The perpendicular drawn from B over the AC. Let us call this as the P. Now the perpendicular simply mean we are given with the angle. So angle P is 90 degree. Triangle ABC is already given as right angle. So angle B is 90 degree. A student, now if we focus over the two triangles, a triangle ABC and a triangle APC, what we are observing? So in triangle ABC, angle B is 90 degree, but in triangle BPC, angle P is 90 degree. If I am just separating these two triangles for your understanding, let me redraw it again. So it is like our A, B, C. Okay, student? Now also redraw the triangle BPC. So how is this BPC? Student, draw in the same order first, then we will rotate this. So this angle is our 90 degree, which is P. This is our B. This is our C. A student, observe carefully. In triangle ABC means focus over the two triangle ABC and triangle BPC separately. I have just separated these two triangles to make you understand. Here we are observing angle B is matching with angle P. Now the whatever the angle C is here, the same line is angle C here. So what we are observing? The two angles are equal because angle B is equals to angle P, both 90 degree. Angle C is common. So a student, is this to appear a similar? How is this? For that, you shall just rotate this, means bring this P on the side BC and send this B on the side AB like this. Means keeping this C as it is, now we are going to rotate this. This is very important. By that you can visualize this triangle BPC is similar to triangle ABC. So how is that? See, a student, whatever this PC length, the same length you have to take over BC. Take the same length. Whatever the length PC is there, keeping the C as it is, take the same length over the BC. Let us consider whatever this CP was there, the same length starting from this C on the side BC, we are able to reach at this point. Okay. Now, whatever the BC length is there, BC length we are considering for the triangle BPC, the same BC length, now you need to consider over AC. So this B is now allocated somewhere here. This P is now allocated somewhere here. Now join these two. Here we are observing that it is like this one. Observe carefully. It will be parallel. So let me exactly match this. So it is the parallel. It will come as the parallel. So draw the triangle properly. So a student, joining this P to the B, this B is now drawn on the hypotenuse AC. We can observe this is the point B. So here the P is again like this. Now, while shifting the P which was earlier on the hypotenuse AC over the side BC and shifting the B over the side AC, we are observing that yes, one triangle is formed like this one, which I am marking here with the, we have actually marked this triangle with the green color. So the green color triangle is this one. So it is this triangle. So it is one triangle. So by this way we can keep in mind very quickly, or we can quickly analyze the question. So that's why I have explained this much. Otherwise proving is, or writing the proof is very simple. So here from the figure or redrawing the figure, we are able to understand that these are the two right angle triangle where the angle C is common. Angle P for triangle CPB is matching with angle B of triangle CBA. Obviously, the third angle will also be equal. It's so simple. So this is one way of understanding that the A criteria is satisfied and the two triangles are similar. Which two triangle? One of the new triangle we have taken. So whatever this new triangle, triangle BCP, the same is drawn here. And another one is the original triangle ABC. Similarly, considering the other triangle ABP, and the original triangle, we can draw the figure, or we can observe that angle B is equals to angle P and angle A is common. Obviously, the new triangle ABP will be similar to triangle ABC. So it is very easy, but analyzing is more important so that you will not forget. A student, the other part, so this is the one thing. So from here we can write triangle ABC is similar to the new triangle we have considered is BPC. A student, we have to keep in mind the B, which was the vertex for triangle ABC, is now written on this side AC. Okay, so for writing the triangle BPC, even if you are observing this yellow triangle or the green triangle, you have to observe it carefully. So it becomes BPC. So these two triangles are similar. It is one thing. Similarly, we can also observe if we are taking this situation like this. So let me explain here now. The other one is like this. A student, again here we can observe that angle B is equals to angle P. Here we have to focus over the triangle ABC and the triangle APB. So in this case, we need to focus over this triangle. So this we need to focus. We are going to focus in this triangle. Another one is our bigger triangle, the bigger triangle that we have already considered. It is like this one. This was the original triangle. So in this case, we are observing that the original triangle is similar to the new triangle. Again, the criteria satisfied is our A. How? Because angle B is matching with angle P and angle A is common. Therefore, the A criteria is satisfied here. So how to write this thing? We have to just write it. And if we want to redraw it, then how to redraw it? So let us redraw it. Again, keep the triangle ABC as it is. Don't disturb the orientation of this ABC. Now, whatever the AP length that you have to draw over the side AB. Why not over the side CB? A student, here we are observing the vertex A is common. We are just going to rotate, means bring the side AP over the side AB and side AB over the side AC. So just rotating it, keeping the vertex A as it is, we can observe, or we can rotate the smaller triangle APB so that it will appear as similar. So that is the concept we are trying to understand. A student, एनालाइजिंग क्वेश्चन इज वेरी इंपॉर्टेंट. एक बार आपने ये तरीके सीख लिए एनालाइज करने के, सोचने के, आप एनटीएससी एंड दूसरे कंपटीशन में इसको पेन उठाकर सॉल्व करने की जरूरत नहीं पड़ती है. जस्ट थिंक इट, यू कैन एंटिसिपेट, दिस इज द वे, एंड आप उसे बहुत इजीली आंसर कर पाते हैं. दैट्स व्हाई आई एम गिविंग यू ऑल दीज टूल्स rather than just solving the NCERT. A student, so draw the line equal to AP over the side AB, a new triangle. So let me draw this new triangle AP. Let us consider this much is the length AP. So draw this length AP on the side AB. So mark this point as P. So this is the point P. Now whatever the AB for the triangle ABP, that we have to rotate or we have to put over the side AC. So put it and observe what we are getting. So this is the side length AB that we are getting. Now join. So the B gets shifted here. Now join it. We are getting, yes, again we are getting the similar kind of figure now appear to us very easily. What is that? The original was ABC, but the new one is our triangle APB. Here we are getting that the angle P is 90 degree for triangle APB and angle B is 90 degree for triangle ABC. In this case, the angle A is common. Therefore, triangle ABC is similar to triangle AP. In place of B, we have the P and the other end is B. Okay, student? So this way, even writing is very easy. What is the cos? So cos we can write here. Angle B is equals to angle P. Angle B is equals to angle P. And angle A is equals to angle A. Why? Earlier it is perpendicular and it is the common. Okay. So we have to just write it. It is one way I have explained. But there is another way or another important way that I want to make you people recall whatever I had explained in class 9. क्लास 9th में आपको हमने एक और भी चीजें बताई थी. आपको ट्रायंगल्स में यदि याद हो तो आप ऐसे रिकॉल कर सकते हैं. देखिए what I had explained in class 9. If there is a right angle triangle, consider ABC and perpendicular is drawn, then whatever the angle X which is between the A, B and P, this is same as angle C. This will also be X. This can be proven here also. So how is that? By this way we can directly observe the triangle ABP is similar to triangle BPC. So this thing we want to understand. So how is that? That approach, let me explain a bit more. A student, but before going through that, let me write. अभी जो हमने चीजें आपको बताई हैं, the explanation is over. Now, take this. Method 1. So this is our method 1 by which we are going to prove it similar. There could be the other method. हम दूसरे मेथड को भी अभी आपको बताएंगे. So in this method, we are going to prove each of the two triangles similar to the original triangle. So let me write this first one here, whatever I had explained, and it is the second one. So take in triangle ABC and the new triangle that we have taken from this figure, original figure is this one, a student, ABC, and the other triangle is BPC, triangle BPC In triangle ABC, the same is done with the reorientation. For the first condition, you may use this one, reoriented condition, or just by observing the original figure. This is our original figure and we are considering this original figure only. So this is the original figure. Considering this original figure, we are writing. So write it. Here we can write angle B for triangle ABC is equals to angle P, but here I shall not write P, I shall write BPC. Angle BPC, since it is perpendicular drawn, it is given. Another, the angle C is common, so write angle C is equals to angle C, since it is common. Therefore, triangle ABC. Now we have to write the similarity. For that, we have to do the correspondence. See, A is not known to us, means what is corresponding to A in the new triangle, so you can leave it. For this triangle, the first place is vacant. Corresponding to B, it is the P, so put it P here. Corresponding to C, it is the C here. So what will be the new triangle? The new triangle that we have drawn is starting from BPC. Obviously, the remaining vertex is only the B, so I have to use B here, BPC. Or you may observe this figure 1, I mean the redrawn figure, where we have observed that for the original triangle A, the angle B, which is drawn over this side AC in yellow, it is corresponding to this. And corresponding to B, it is this one, P, and corresponding to C, which is common. So triangle ABC will match with triangle BPC. See, BPC, whatever we have written. Okay, so this is very easy to write. Many times students are facing difficulty in writing this. आपको यही लिखने आ जाते हैं तो क्वेश्चन बहुत इजी हो जाता है. So it is one thing. So take this as equation 1. Again, in triangle, take the other triangle. So write the other triangle. So let me write side by side. In triangle ABC, and the second we are considering, the new triangle is our ABP, you may write initially, and ABP. So these are the two triangles we are considering, and we want to equate their angle. Here we are observing the angle A is common. आपने जो रीड्रॉ कर लिए हैं इसे भी आप देख सकते हैं और ऐसे ओरिजिनल फिगर से भी आप देख सकते हैं एंगल A is common. So here we can write angle A is equals to angle A. Why? It is the common one. The other one is coming to this angle B. Always watch in original figure, or if you have redrawn it, you can watch the redrawn one also. Angle B is matching with angle P. So right, angle B is equals to angle P. Why? Each perpendicular. So it is given in the question and it is drawn in the figure. So by A similarity, we can write triangle ABC is similar to triangle. Now, observe carefully. A mean the same thing. So we have to start with A. What is corresponding to B? Again, it is corresponding to P that we have taken in the proof. So from here we can write. And the remaining C, for this C, the new triangle is considering the vertex ABP only. And in this, we have already considered A and P. So remaining one is the B only. So it will be our APB. It is this. So student, do not get confused. The B that we have written for the bigger triangle here and B for the smaller triangle here. Okay? It doesn't mean B should be on the same position. No. Here angle A is matching. So angle A or vertex A is at the position of A. But corresponding to vertex B, the P is matching. So we have to write P here. Then the remaining, the C, the new triangle consists of this vertex APB. So remaining C will match with the B. So this is the way. Why? By A similarity. The cause you also have to write. Take this as 2. So from 1 and 2, what we can write? From 1 and 2, we can write triangle ABC, means we have to club these two equations together, is similar to triangle BPC, is similar to triangle, the new one is our, another new smaller triangle is APB. So this was the original triangle. These two are the new triangle. So thus, the new triangle are also similar to each other and they are similar to the original triangle. So new triangle are similar, or we may write directly as all the triangles, all 3 triangles are similar to each other. Similar to each other. Okay, student? It is one thing that we have to keep in mind. So it was the method 1. But I want to tell you something additional. Whatever the concept we were applying in class 9, so those things we need to recall. A student, I had explained everything. This explanation is more important here for learning. For writing, just you have to write this much, it is enough. But before writing, you must know how we are doing this, how to analyze a question. That is more important. Now let us go for the another way or another small concepts that we are writing as the method 2. Here we are going to use the concept of class 9, not even the concept of class 10th. But do not think if you are adopting this approach then it is wrong. It is even rather more convenient or more explanatory than the first method. So write this as ABC. And we have drawn here perpendicular P. It is like this. In this case, we have to observe what are the triangle formed and what the equation can be written. A student, in triangle ABC, let me mark the other angle by 1, 2, 3 or XYZ for ease of writing. Let us write this angle as X and this angle as Y in our original triangle. And while BP is drawn perpendicular, mark this as U and the angle PBC as V. A student, we have marked this. These angles. Okay, just for ease of writing, rather than writing triangle ABP, I will just write U. It is for ease of writing only, and this method of assuming or marking is also acceptable in question, in examination. Now, if we consider the triangle ABC, recall your class 9. In triangle ABC, you forget about the UV and other perpendicular. I have simply like this ABC. It is this much. It is 90 degree. This is X. This is Y. What I can write? So in this triangle, I can write X plus Y is equals to 90 degree. Can I write like this? Yes, surely we can write. No doubt. Now take any of the new triangle. Now in triangle we may consider ABP. ABP. How is this triangle? Keep the orientation as it is. Let us draw it. I will not draw the other extended part. So A, the perpendicular P, and it is like this. A, B, and the perpendicular P. Here we are getting this is 90 degree. The angle A we are assuming as X, and this angle we have assumed this as U. So while one of the angle is 90 degree, what we can write? X plus U is 90 degree. This gives us X plus U is equals to 90 degree. Now, from 1 and 2, what we can write? Everything I had explained in class 9th also, a student. You people might have forget. So from 1 and 2, we can equate this to X plus Y is equals to U plus X. Now this X and X getting cancelled. Y is equals to U. See? How is the figure? Now let us analyze this. What this tells? What is in our original figure? Here we have obtained Y is equals to U. I was saying the same thing. Means if I consider the angle formed between ABP, this will be equal to angle C. Are we getting now? So it's so easy way of understanding or writing. So just you have to take the two triangle, you have to cancel the common thing. It's enough. Similarly, we can also prove angle V is equals to angle X. What to do? You have to take the original triangle ABC in which X plus Y is equals to 90 degree, and another new triangle you have to take BPC. So take this as the 3. Now take the new triangle in triangle BPC. So one condition is proved, means this we have proven. Take the other triangle BPC now. Triangle BPC. So this triangle is like this one. BC is there, this BC is there, this one and this one. This kind of triangle we are interested to take. Okay, student? So draw in the same orientation. And this is our perpendicular. It is our B, C and P. Here this angle is our V, this angle is our Y. So here I can write V plus Y is equals to 90 degree. Take this as 4. Now we have to compare 4 with the original 1. So from 1 and 4, what we can say? X plus Y was 90 degree and 4 is V plus Y is also 90 degree. Each of these are equal. Y getting cancelled. This implies X is equals to V. So this is the other proof. This you may write as the 5th one. So this way, if we are taking the two triangle ABP and triangle PBC, we can write V is matching with X, means this V is matching with this X, and the U is matching with Y. So this you have to keep in mind. So the Y will be equal to U, which is the smaller triangle on the other segment, but in opposite orientation. So this one is matching with this. So these are the things that we need to keep in mind. So now this way we can take the two triangles independently and we can prove these two are also similar. So right, if we are taking the two triangle, therefore in triangle, now let me write ABP and BCP. ABP and triangle BCP. If we are taking this one, here we are observing that A is going to match with V, means X is matching with V. So ABP on left hand side we are writing, so write this as X. This is matching for the other triangle is our V, so write this as V. How we have proven in above? Then U is matching with Y or Y. So ABP, so for this X we have taken, another side is our U. So we have to keep U on left hand side. This is matching with Y. So this we have proven from 5 we can write, and this already we have proven from 3 we can write. Okay, when the two angles are equal, the two triangle will be similar. Therefore triangle ABP, student, now again we have to allocate the corresponding vertex corresponding to A. Observe it. Corresponding to A, we are observing it is the V, means it is falling on the vertex B, means this A for the smaller triangle ABP is falling on the B for the smaller angle V. So I shall, in place of A for the other side, I shall start with this with the B. The other one, AB we have taken, corresponding to this B which is for the U, it is this C. So this U is matching with Y, means for the smaller triangle ABP, the vertex for B is this C in other triangle. So write wherever B on left hand side, on the right hand side we have to write as C. Now corresponding to this P, what we are observing, the P is the same because both are 90. So the P will remain same. Or a student, even we are observing that in this case the P on one side or one of the triangle is 90 degree, the same P on the other is also 90 degree. This way we can also write. So that's why this P is equals, or P is occupying the same position. You may also write here angle P is equals to angle P each 90. Or even if you are leaving it, that doesn't matter. So the purpose was to make you understand the sum of the two angle is 90 degree. That concept can also be used for proving the similarity. So these are the things what we are coming oftenly in the question. So this thing or this condition arises in the question. So these two triangles are similar by a similarity. So this way we have proven the two different triangle or two triangle form on the two part of the hypotenuse are similar. and each of them is also similar to original one, you also have to go by the same way, or again you may write here angle B is equals to angle P, angle C is common, so one of them will match with the original, so it becomes similar. So these are the things that we need to keep in mind. A student, while I have proven this as similar, what is the purpose? The purpose is to write the ratio. That is important, a student. It is not written in the book or written in the theorem, but from this what we can get, that is more important. A student, if I consider triangle ABP similar to triangle BCP, what I can write? I can simply write, without going in the figure, I can write AB by BC. Just take first two of the first side, first two of the other side, means right hand side, the next two BC means BP in numerator corresponding to our CP also equals to AP by the other one is our BP. It is one thing. A student, if we observe carefully, we are getting something. What we are getting here? A student, if we observe this, take this as 1, this as 2, this as 3. So from 2 and 3, what we are getting? So from 2 and 3 here, just rewrite it. BP by CP is equals to AP by BP. Do the cross multiplication. So this implies BP and BP into BP is equals to CP into AP. So left hand side become BP square is equals to CP into AP. This was the question in previous exercise also. Are we getting? Means, a student, here we have observed that this BP square means this is our BP, the perpendicular drawn. That square is equals to CP. Let me redraw this here rather than contaminating again and again our original figure. So the figure is ABC, BP is drawn perpendicular. Then here we are observing that this BP, this much square is equals to our CP. Where is our CP? CP is this one. Observe this one into AP. Are we getting? So this is the question asked. So question are very simple. I'm not taking the textbook question and solving it, but I am solving all the questions. So directly it is asked in your exercise, the question is given, you have to prove this one. So the same way you have to prove, first you have to prove these two triangles as the similar independently by applying sum of the angle as 90 degree. Then you have to write the ratios. You have to select the suitable ratio from these three ratios, only two suitable ratios to get the required result. This way you have to proceed. So questions are very simple, student. This is the question in your textbook and I have answered it here. You will just separate this part and write it. It is one thing that we have written. A student, what else we can write here? What more is there? A student, let me take this part or the original part. Our original figure was this one, and here we have proven original is this figure. Take this Let us copy it for the next page for analysis. Whatever the new ratios that we can determine and what are the importance of that. It is very important to understand. And by this way, we are able to reach to Pythagoras theorem. Don't worry. So Pythagoras theorem we are proving. These are interrelated. I had already told you. So here we had proven by method 1. We had proven this is similar to the triangle this one. Why I am selecting this student? Because we have written their vertex wise, means which vertex is corresponding to which one, that wise. So for writing the ratios, we need this similarity written at corresponding vertex. So students, here we had proven that the two are similar. The two triangles are similar, and that similarity we had proven one thing in last page. Finally, we have proven that the original triangle is similar to the two new triangles. Now observe carefully and let me rewrite everything. What are the possibilities? So also we have this original triangle ABC, and two new triangle we had proven. This I have written. From this, what ratios we can write? So while considering the first two, I can write the ratio, because considering the last two, I had already written the ratios in last page. Considering the last two, we had written these ratios, and we have proven one of the important results. Now considering the first two triangle ABC similar to triangle APC, what ratio we can write? So this implies, considering the first two triangle, so let me just separate this, rewrite it. Triangle ABC is similar to triangle BPC, therefore we can write the ratios. Ratio writing is very important, because question is indirectly asked in writing the ratios. Everything is just to write the ratios. You have to rearrange it. What is the required one? AB by BP. This AB on left hand side we have taken, BP on right hand side, is equals to BC on left hand side and PC on right hand side we have taken. This is also equals to the first and last, AC on left hand side and BC on right hand side. A student, again let us understand what we are observing. Considering the last two, only, what we can write? So here we can write BC into BC is equals to PC into AC. This means BC square is equals to PC into AC. This is the other way. So take this as equation 1. Now I am taking as a fresh. Observe, a student, let us understand this very carefully. Our triangle is like this, triangle ABC, where angle B is 90 degree. We have drawn the perpendicular from B to P over AC, we have proven this result BC square. So let us again allocate it. BC square. Where is BC? This is our BC square. Okay, student. So this BC square is equals to PC. Understand carefully. PC, allocate it. Where is our PC? PC, this much length, into AC, this much length. Student, this is useful in our Pythagoras theorem. So that's why I have allocated. It means one of the side square is equals to the product of the perpendicular length from one of the vertex whose side square means which vertex whose side square is considered. Means observe here, this C is common here. So it is our PC into the hypotenuse itself. Okay, it is this one. So keep in mind, C is common. So always start with the common vertex. So CB square is equals to CP into CA. This way you may keep in mind. So the better way of writing this, because based on this MCQs in NTSEs and even in your academic is also framed. So keep in mind, one of the side square is starting with this C. Start with this C, right? This side means perpendicular side square. BC, this square. Start with this C, go on the hypotenuse, the possible segment touching this C. The possible smaller segment is our CP into the bigger segment is our CA. This you need to keep in mind in this fashion also, because many a time directly the question is asked, say BC length is given, AC length is given, and you need to calculate this PC length. What will be PC? If you have this concept in mind, you can quickly write, and the same question will come in our circle. Why? We will learn there, if BC is a circle or the diameter, then it will form a circle like this. At this time this is 90, so this square is equals to this into this, that will be formed. So this concept we will learn later, so right now do not get confused with this one. So you just leave it, but keep in mind, one of the side square BC square is equals to, start with the C means the vertex which is common or whose square is taken, means the acute angle vertex. There, from that vertex you have to start and you have to write BC square is equals to CP into CA. इसे आप याद करके रखिए. Though in book it is not given to remember this, but please keep in mind, it is very useful. ये अभी आपको यूज आने वाला है आगे के चैप्टर में भी, आपके NTSE में भी, और डायरेक्टली क्वेश्चन आर आस्क्ड. Say BC is given and CP is given, then calculate AC. Will you try to write the Pythagoras theorem again and again and solve it, or proving the similarity? No need. Just you are observing that C is the common and BC is common, so start with the C, right? CB square, Mr. Start with the C, CB square directly. So this CB square on one of the perpendicular side, go on the hypotenuse side, CP, CA. It's so simple, very simple student. यही आपको ध्यान में रखने हैं. So start with any vertex, take the perpendicular side and then take the side or the segment over the hypotenuse. So it is our C and B that we have taken. We have started with this C, the same C, the same C. ऐसे आप याद रखें, इजी है, बहुत इजी है ये. So ये कॉन्सेप्ट बहुत इंपॉर्टेंट, बहुत यूज आने वाला है. So one thing we have proven by considering the first two triangles. Now let us come for the other. Let us consider the first original triangle and the last triangle. If we are taking these two triangles, so take from also, or write also triangle ABC is similar to the triangle. The other triangle is APB. Now, from this, the ratio that can be write directly by observing this. No need to go in figure again. So write it. AB by AP is equals to BC by PB is equals to AC by AB. This we have written. Is it okay? Now observe which one is able to give us a square. Observe the denominator and numerator. Here we are observing AB is in numerator and AB here in denominator. So I shall take first and third here. So write from 1 and third of the ratio that we have written. What we have? AB by AP is equals to AC by AB. Observe, student, what we are getting. Very nice. AB into AB is equals to AP into AC. Observe this, what we are getting. AB square is equals to APS into AC. Is it okay? Now, again, understand this. Draw the figure. Observe what is this representing. Again, I am drawing the figure above this. Consider the ABC. Our P is the perpendicular, not on a scale, so slightly correct it. A, B, C, and this is our point P. Here we are observing. Observe again carefully, student. AB means one of the perpendicular side. Here we are observing this much square. Is it okay? Yes. Is equals to the acute vertex is our A. Now move on the hypotenuse side. AP and AC, their product. Is it okay? A is common. So in this case, we need to keep in mind, if we are writing AB square from this vertex, then this is the perpendicular side we have taken, or one of the perpendicular side we have taken. So we need to write for the hypotenuse segment, means on the hypotenuse, what are the segment? Starting from the A, it is our AP, another one is our AC itself. Is it okay? So this is the other one. So this way, depending on whatever the perpendicular side given of the bigger triangle and whatever the segment given on the hypotenuse, we can choose these two we have observed. A student, very interesting thing. It is this one. So mark the second equation that we have, or second AB square is equals to AP into AC as equation number 2. Okay, student. Now let me highlight this. From the first triangle, or one of the triangle with the original triangle, we have this one. BC square is equals to CP into AC, or BC square is equals to CP into CA, you may write. Keep in mind, that is rather more convenient. From the second, we have proven this one also. Now we are going to add 1 and 2. What we will get? Can anyone tell me? It's very interesting and very easy. Here we have observed in this triangle, from the first BC square we have calculated, and from the second AB square we have calculated. So right, adding 1 and 2, what we can say? AB square, let me write the AB square first. AB square plus BC square on left hand side. Right hand side we also need to put it. So for AB square we have AP into AC. For BC square we have PC into AC. Is it okay? I hope so. Now keep this left hand side as it is. What we are observing, AC and AC is common. So since this AC is common, we can take this out. This AC and this AC, these two AC are common. That can be taken out. So take this out. The remaining thing will come inside the bracket. So take this AC outside the bracket. For the other one means whatever the left with the first term is our AP, and the leftover from the second term is our PC. Okay, student. Now observe. Now again come back to the figure. Come back to the figure. How is this? Our triangle is ABC and perpendicular P is here. AC is out. AP this much length and PC this much length. What it become? This become AC. Is it okay? This is same as the length AC. So this inside the bracket term can be written as AC itself. So right hand side become AC square. See how interesting is this? AB square plus BC square is equals to AC square. And whatever this relation obtained is called as Pythagoras theorem. So this mathematical relation is Pythagoras theorem. This we have to keep in. We are using this since class 6 or class 7, but we have proved in class 10 with the help of similar triangle. A student, keep in mind, proving of basic proportionality theorem, BPT. BPT also called as the Thales theorem. Okay, no? So proving of that Thales theorem and proving of this Pythagoras theorem, these two are present in your syllabus. And इसके प्रूव आपको पक्का से पूछे ही जाते हैं. तो जिसके प्रूव आपको नहीं पूछे जाते हैं, हमने उसका डिटेल एक्सप्लेनेशन नहीं दिया है, बट जिनके पूछे जाते हैं, I have explained this. So write what is Pythagoras theorem. So whatever this we have obtained, it is called as Pythagoras theorem. Where is Pythagoras theorem? No, it is not the Pythagoras theorem. So this is our Pythagoras theorem. So whatever we have copied here, let me copy there. Student, proof of Pythagoras theorem is very useful to you people. आप ये भूलिए नहीं पाइथागोरस थ्योरम. पाइथागोरस थ्योरम, बेसिक प्रोपोर्शनलिटी थ्योरम, इस दोनों में से एक ना एक पूछा जाएगा आपको. So this is called as Pythagoras theorem. So this way the Pythagoras theorem is also proved. So I will not prove it again. I had already proved. So even if you have to prove the Pythagoras theorem, a student, you have to first prove the similarity. You have to write these equations that we have written. Then you have to add them, you will get it. So for proving the Pythagoras theorem, what you need to do? You first prove the triangle ABC similar to triangle, whatever this, the three that we have taken, triangle BPC, triangle BPC similar to triangle ABCD. PB. This you have to prove. Try to prove it by method 1. Method 1 में जो हमने explanation दिए हैं, you must use that method. That is even convenient of proving all the three. Then you have to write the ratios of this page. Whatever these ratios, the two I have taken, that. So only this page explanation. So first you have to prove this, then use all explanation of this page only. So this much only you have to write. Means the page number 2, this whole you have to write. This method you can leave it. This was the additional thing. And here. So for proving this, you must start with this one. Let me mark it here. Student, for proving this, you have to start with the figure. The figure that you need to draw is this figure. Means here you have to do the construction. Construct BP perpendicular on AC. So here you have to write this construction first. Then you will proceed. So first you have to write down the construction here. Construction BP perpendicular on AC. This construction. Then you have to start with the proof. So you have to write everything whatever written here in this part. Coming to this part. So this will continue. This much you have to write. This figure you have to draw. BP construction you have to do. Then you have to write this much part. Then you have to directly jump to this one. With that you will write these triangles similar. Then you will directly jump to this one. Means this similarity there we have proved. Then you have to take this similarity in pair. You will write this. By considering the first two triangle, you will write this one. Then considering the first and last triangle, you will write this one. Then you will add the square of the sides. You are able to reach this one. Okay, student. So this much only you have to write. If the statement is required, you have to first write this statement at the top. Okay. So proving Pythagoras theorem is very important and very easy. So it was all about this one. How to apply this Pythagoras theorem for the question and numbers we have done many times and even earlier classes also. Now let us go for the question. A student, let me do this question, which is very easy, but still I will do it. Because this question is asked many times in MCQs. A vertical pole of length 6 meters. So draw pole of length 6 meters. So this 6 meters is the length. Cast a shadow of 4 meters. Means the shadow over the ground is 4 meters. So it is something like this. The 4 meters you just take. You may consider the pole or name this pole as AB. The shadow is reaching up to C. BC is also given as 4 meters on the ground. At the same time, a tower 20 meters long. Now at the same time, it is given that a tower must be there. It is our 28 meters. You may name this tower as PQ. So what will be the shadow length? Now, Student, what this figure recalls or remind you? This simply tells that while the sun is at the same height, the shadow or the two triangle which is formed by considering the vertical height and the shadow as the two sides of a right angle triangle. So these two right angle triangle are similar. It simply tells us that much. So we need to apply the similarity condition. Getting? Because the sun is at the same height. So this angle of elevation of sun and angle of elevation of sun for the pole as well as for the tower remains the same. Whatever this angle of elevation, x and x you may consider, or theta e you may consider, because the shadow is always found from the top or the topmost point to the shadow end on the ground. So angle of elevation theta e are equal. Get it? So here angle B is equals to angle Q. Why? Perpendicular. Both are perpendicular pole. So right, perpendicular means the pole and the tower both are perpendicular on ground. On ground. It is one thing. And other one is what? The angle theta. So we may write angle C is equals to angle R. Angle R is for the tower. So why? For the same time or at the same time the angle of elevation of sun will be same, whether you are observed from the Kaiga or whether you are observing from the Karwar, the angle of elevation of sun will be same. So therefore the angle of elevation, so same angle of elevation of sun, angle of elevation of sun. So therefore the two triangle ABC is similar to triangle PQR. Therefore we can write the ratios here. AB by PQ is equals to BC.
Sir,
Yes.
sir, 28 meters the length of the shadow.
Yeah. Okay. Good to recall me. Okay. So whatever the length will be there. So just we have to change the position of this 28. Very good. So 28 is our QR, but the figure remain as it is. Whatever the length of this tower L that we want to calculate, it will be something. But the situation remain unchanged. So BC by QR is there. Another, even if the hypotenuse length is given, that can also be correlated. Better habit is you just write it but do not take it. Otherwise many times our student get confused which side we shall take. So better habit is to write all the ratios and you choose the two ratio which can give us the result. That is the way. While writing all the three and choosing the two, that is not going to deduct your marks, but that gives better impression for the copy checker or to your teacher. Yes, you have applied the concept. So put those good habits. Now what is required here? Here we are observing the perpendicular and base, only these two are the required. So we will take the first two, substitute it. AB is our 6 by the length L we want to calculate. Substitute it L itself. Another one is 4 and QR is our 28. So just calculate this. Do the cross multiplication. 6 into 28 is equals to 4 into L. So this implies L is 6 into 28 divided by 4. So 7, it is our 42 meter. So this implies length of tower is 42 meter. Okay, student. So this is how the MCQs are framed, or a smaller question are framed. If it is asked in the 4 marks, then you may need to write this part also. But if it is not asked in 4 marks in MCQs, then you have to just recall in your mind, you have to write this side ratio directly and you can calculate the length. Okay, so it is very easy. So it is one way, but our purpose is analyze a bit more. What is that? It is the two right angle triangle, and in right angle triangle, wherever the right angle triangle, what comes in our mind? Pythagoras theorem, another one is trigonometry. So can we think in the line of trigonometry? Surely we can think. Okay, student. So write down the method 2 also. So write for the method 2. This is our trigonometry method. We have already finished trigonometry. Here, the angle theta is same in the both cases. The given side is related with the angle by trigonometry. So we can apply the trigonometry here also. If I am going to apply the trigonometry, then in triangle ABC, I can write tan of angle C is equals to 6 by 4. Okay, or tan of theta E we can write. But in triangle PQR, tan of angle R is equals to the length L we want to calculate, and 28 is given to us. Is it okay? But here, because of the same condition, means the sun is at the same elevation, this condition we can keep in mind. Angle C is equals to angle R. So while the angle are same, tan of angle C is equals to tan of angle R. It simply means 6 by 4 is also equals to L by 28. Are we getting the same thing? Yes, we are getting the same thing. So this simply means L is equals to 42 meter. So simplify it, you will get the same result, 42 meter. So this is the other way. So mathematics always mean you need to search the possible ways, because trigonometry makes the mathematics very convenient. So by using the trigonometry, we can also solve. So in MCQ, whether you are solving by considering the trigonometry or similar triangle, that doesn't matter. Okay. So this was all about this question. Now let us go for the next question. The ratio of area of two similar triangles that we want to calculate. Again, whatever the similarity concept that we have learned, the same thing we also have to use here. But here we are interested to know the area. So how to get it? Let us do this theorem. It is very easy, and this question is also asked. Means this theorem is also very important. आप 3 थ्योरम कर करके जाइए इस चैप्टर से. रेशियो ऑफ एरिया ऑफ ट्रायंगल, देन पाइथागोरस थ्योरम एंड बेसिक प्रोपोर्शनलिटी थ्योरम. बेसिक प्रोपोर्शनलिटी थ्योरम के प्रूफ हैं, पाइथागोरस थ्योरम एंड ये भी हैं, बट इसके जो कन्वर्स और रिवर्स होते हैं एंड एसएएस एएस, इन सब के प्रूफ इस बार आपको नहीं पूछे जा रहे हैं. सो लेट अस डू दिस. So our next theorem is like this. A student, what this theorem mean? This theorem simply tells that if you have the two triangle, you are free to draw the triangle in any shape. So always draw the two triangle and another triangle also. So let me take the triangle ABC and PQR. So irrespective of type of the triangle, if I take the area of triangle ABC to area of triangle PQR, if these two triangles are similar, then the ratio of their area is equals to, take the ratio of their side, corresponding side. If AB is matching with PQ, then AB by PQ, this much square. Or even you are free to write in the form of AB square by PQ square. Not only one of the side, you are free to take the other side also. If BC is there, same as BC square by QR square, same as the remaining third side, AC square by PR square. It is this. Okay. So the theorem is like this. Ratio of area of two similar triangle is equals to a square of the ratio of their corresponding side. How we have written this way. So how is the proof? Let us write it quickly. For proving this, wherever the area is required, we need to draw perpendicular to know the area, because area is given by perpendicular into base. So take the two triangle. Let me draw the two triangle as ABC, another triangle as PQR. Here, the triangle ABC is similar to triangle PQR. So here it is, in this theorem itself is there. So what is given? The given condition is triangle ABC is similar to triangle PQR. A student, triangle ABC is similar to triangle PQR. What does it mean? Is this only a statement? No. A student, this gives you two equations or the three ratios. So you must quickly write while it is given. So in your mind, you shall always think in the line of ratio, because मैथमेटिक्स में आपको सॉल्व करने हैं या तो रेशियो या किसी न किसी चीज को सॉल्व करने रहेंगे. So you shall keep this in your pocket. AB by PQ is equals to BC by QR is equals to AC by PR. A student, wherever given, you can directly write this way. It is correct way of writing. Many times our students are hesitating. This is given as similar. Corresponding to this similar, what is the conclusion that we can draw? I have written it here. It is okay, or it is the good way of writing. It is one thing. What is required or to prove? Write that area of triangle ABC by area of triangle PQR. This is equals to any two side. Ratio of any two side means AB by corresponding to this AB. Another one is our PQ, their square, is equals to, if we are taking the BC, we have to keep in mind ABC we have taken in the numerator. So the corresponding side will be also in numerator. Means the side of AB have to be taken in numerator first. By QR, their square. So square is important here. Then the AC by PR. This is to be proved. How to prove? We need area, means we need the perpendicular. Always, without knowing the perpendicular or all the three sides, we cannot calculate the area. So I need to go for a construction or a small construction. What is that? Draw from A on side BC, draw a perpendicular. You are free to draw from the side, from the vertex B on side AC also as the perpendicular. You are free to draw. At that time you shall take AC as the base. Okay, if you are drawing the perpendicular from the side or from the vertex B, then in triangle PQR you shall draw the perpendicular from Q also. Okay, this way you shall draw. So you are free to draw any of the perpendicular. So while drawing the perpendicular from the vertex B on AC, I shall take AC as the base and this as the perpendicular. And for this triangle, I shall take PR as the base and Q, let me call this as M and this as N, means QN as the perpendicular or altitude. So these things you have to keep in mind. So the purpose is to just construct a perpendicular. We are free to draw at any of the side from the opposite vertex, but for convenience of understanding and analysis and observation, just by looking, commonly we are drawing it from the vertex to the horizontal base. So take this, I'm going to take BC as the base. At that time I need to draw a perpendicular from A on BC. Consider this point as M. Draw this perpendicular, and from the P, similarly draw the perpendicular. Call this point as N. Is it okay? Now it is okay. A student, so whatever the construction we have drawn, draw AM perpendicular on BC and AN perpendicular on QR. Okay, student? Now we need to calculate the area. So let us start. So the two triangle ABC and PQR are similar. It means their sides are proportional, their angles are equal. That thing is available to us. Okay, now let us take the area of triangle ABC. Can be written as half the base BC, because perpendicular drawn is AM. Take this as 1, and the area of triangle PQR, this is given by half. In this case the perpendicular is AN, so base is our QR into PN. Now take the ratio. So these two things we have written as it is, taking the ratios. So this implies area of triangle ABC by area of triangle PQR can be written as half may be cancelled, BC into AM by half of QR into PN. This half gets cancelled. I can write this as BC by QR. BC separated, BC by QR. Why we are separating? Just you will understand. Into AM by PM. I have separated this BC and kept this QR below it, because the BC is the side length of triangle ABC and QR is the side length of triangle PQR. And this BC by QR is known to us. Therefore, I have separated this. Okay. BC by QR I have written first. Then we have written the other. So it is our BC by QR. Now our purpose is, if we are able to prove this AM by PN is same as BC by QR, we can replace this AM by PN by BC by QR, it becomes the square. So simple thing. But how we can get this ratio AM by PN? A student observe, AM, I need this much length and PN. For that, I need to take the two triangle to get this ratio. So you are free to take the triangle AMC like this one. Then PRN means PNR. You are also free to choose AMB than PNQ. Okay, let me choose AMC and PNR. A student, write this. In triangle ANC and PMR. Here we are observing triangle ABC is similar to triangle PQR. It simply means angle C is equals to angle R, in addition to the ratios that we have written here. So also, if you wish, you may write here angle A is equals to angle P. This gives this thing. Angle B is equals to angle Q. Angle C is equals to angle R. These are the additional things. Wherever required, the ratio or angle, we can use it. So here we need to prove these two triangles as the similar. So therefore, we have taken these two triangles. So in this case, the triangle, we have drawn the perpendicular. So angle AMC is equals to PNR. Angle ANC is equals to angle PMR. How? Each 90-degree by construction. We have drawn the perpendicular. It's simply. And angle C is equals to angle R. Why? It is given. Given is triangle ABC similar to PQR. So the angle C is equals to angle R. So we can write angle C is equals to angle R. It is given. Triangle ABC is similar to triangle PQR. Therefore, I can write triangle. Now, what is there? M is corresponding to N and C is corresponding to R, and we have chosen the triangle AMC and triangle PNR. So triangle AMC is similar to triangle corresponding to A. We have the P, or even you are not getting this A corresponding, then from M and N here we are getting the triangle AN is on the left hand side. This denotation is N. ANC corresponding to N we have the M, so write the M first. Corresponding to C we have the R, so write the R. So remaining is what? Here A, and it is starting with the P, so we must put P here only. It is this much. While writing this similarity, what is available with us? Equation. Not even one but two, or the three equations or three ratios are equal. That equation. How to write? Very convenient. Take the first two. AN by PM is equals to NC by MR is equals to AC. Take this by PR. It is this one. Students, these are the three ratios. What is these three ratios? What is the use of this? Now you observe whatever I have marked here in yellow. Our purpose is to get AM by PN. AM, sorry, AN by PM. It is like this one. Student, PQR. Sorry, M is in first, N is in second. AM. AMC. I have just written something. M and N positions are interchanged. Student, slightly correct it. आप लोगों ने भी ध्यान नहीं दिला है. It means you people are sleeping. Triangle AM is here, N is here. M and N, slightly correct it. Correct this sign. M and N. Okay, I will rewrite it. AM is there, N is there. AMC PNR. Yes, it is taken like this. AMC PNR. So MC PNR. Yes, write down the ratios. AM by PN is equals to MC by NR is equals to AC by PR. We will finish in next 10 minutes only. Don't worry. Now here we have AM by PN. So take this AM by PN and match it with this one. Here we are observing that this AM by PN can be replaced by AM by PN is what? It is the perpendicular. Can be replaced by its side length AC by PR. Though this is also equals to MC by NR, but that is not useful. So I shall use this one and this side length, this one. So from this, we can write AM by PN is equals to AC by PR. Take this as the ratio of the two area. I have taken that as 1, and whatever this AM by PN we have calculated, take this as 2. So substitute 2 in 1. So 2 in 1. What we are able to get? Area of triangle ABC by area of triangle PQR is equals to BC by QR is already there. Keep it. QR into, it was AM by PN, so I can replace it by AC by PR. But still we didn't get BC by QR. Now this AC by PR is same as BC by QR. Why? It is given. So that way we can write. This is same as BC by QR into AC by PR. Observe this. AC by PR, this one, same as BC by QR. From the given condition, the two triangles are similar. I can use this one. I had taken this as 1, then I shall take this as 2 or 1 dash, you may write, rather than more cut bit, 1 dash. So from 1, we can replace it AC by PR by BC by QR. Why? Since AC by PR is equals to BC by QR, that from the first we have written. This is even also equals to AB by PQ. So equals to AB by PQ. It is given that two triangles are similar. So this becomes equals to BC square by QR square. So it's so simple. But this BC by QR is also equals to AC by PR. So this can be written as equals to AC by PR, their square can also be replaced, or this square can be brought in the same bracket, means above the same bracket. So I can write in this way also, their square. Now this AC by PR is also equals to AB by PQ. So this way we have proved that, thus we have proven area of triangle ABC by area of triangle PQR is equals to, take the any two sides, AB I have taken first, this AB, just by observing this we can write, then PQ, their square, also equals to BC numerator by QR, their square, is also equals to AC numerator by PR, their square. Okay, student. So this was the final statement that we have proven. Okay, student. So this is very important, and the question based on this we had already done earlier. How is the question framed? So it is this one. So questions are very easy. But you need to practice a bit more, but because without practice you cannot get the better understanding. Okay, so shall we stop? I hope so. A student, yeah, this is a small question. Already we have done it, but once again let us do and let me explain. It is based on this, the same concept or the same theorem, whatever we have learned. What is given in this figure? The line segment XY, the figure is given, is parallel to AC. Here XY is parallel to AC. What does it mean? It simply means the triangle, say XYB is similar to, corresponding to this X, the angle A is there, triangle A, and corresponding to this Y we have this C, and B is the common vertex. It simply means that. Okay, so parallel to AC of the triangle, and it divides the triangle into two equal parts. It is given that whatever the area that we are getting for this XYB, the triangle XYB, this area is same as the area for the trapezium that is formed here. Other side there is a trapezium which is formed. So student, here we have to keep in mind the two areas are equal. That much information is given to us. But for getting this AX by AB, AX, that we need to calculate by AB, this we need to calculate. A student, AX is, for AX by AB we do not have any formula. We have the formula for XB by AB or BX by BA. But this BX by BA can be converted into AX by AB by applying componendo, dividendo, or basic proportionality theorem. Their deduction, whatever we have done, there I had explained how to convert it. So for applying the formula, first thing we need the area of the triangle ABC and area of the triangle XBY. Here, if we consider the area of the triangle, say XBY as X, or say the small a, then area of triangle ABC will be A plus A. It becomes 2A. Okay, so the simple thing that you have to mark, let us consider this area as A, or yes, mark this by A1, and this area is also A. The two area are A. So it is, the other given thing is area of triangle BXY is equals to area of trapezium, our X, Y, C and A. Now area of triangle BXY is okay, but we need the area of triangle ABC or BAC. BAC. Observe this figure carefully. The bigger triangle. This is equals to area of triangle BXY plus area of trapezium. So that trapezium is known to us because these two area are equal. Area of trapezium XYCA. I am considering the area of triangle BXY as A, then this is other A, this is 2A. So here we have assumed, just for taking the ratios, area of triangle BXY is equals to A, or directly you may write, or even if you do not want to assume or introduce this variable, you may directly use this. So it is up to you. In place of this trapezium, I can substitute this triangle. So this trapezium I need to replace by this one. So this is area of triangle BAY plus area of triangle BAY. I can write it twice. So it becomes twice area of triangle BAY. So how do you feel comfortable? You can write it. So this is area of triangle BAC. Means bigger triangle area is twice the smaller triangle area. This implies area of bigger triangle, means I can write this in this fashion. Area of triangle BAC by area of triangle BAY. Just I have brought this in the denominator, student. It is simply 2, or we may write this as 2 by 1. Yes,
Sir,
yes, हाँ बोलिए विवेक.
sir, it is
आर यू नॉट गेटिंग? BAC बिगर ट्रायंगल हमने न्यूमरेटर में लिया है लेफ्ट हैंड साइड में. इसको हमने पहले दो में, एक पहले स्मॉलर ट्रायंगल BXY एंड ट्रेपीजियम XYCA इसमें लिखा. देन दिस ट्रेपीजियम XYCA is again replaced by triangle BAY because it is given that this line is dividing the triangle into two equal parts. So that's why I have written this. Okay, so this much information are given to us. I have used this given information to know the area. Bringing this right hand side BAY in denominator, we have obtained this 2 by 1. Okay. Or you are also free to write this area of triangle BXY. Good. You were saying perhaps that thing. Good. It is not BAY, but it is BXY. Very good. So it is our BXY. So write BXY. So write this as BXY. This is the smaller triangle by area of the bigger triangle is B, A, and C. It is this one. Okay. We may write this as 1 by 2, taking the reciprocal. Any of these two ratios can be taken. Now, since by formula we can write area of triangle BXY by area of triangle BAC. Observe, student, BXY means the smaller. The smaller we may choose like this. So we can choose like this one, this length by this length, or we can choose this much length means BX, and the bigger length what I shall choose is this much means BA. Okay, which we shall choose. The question is asked in the term of X, so I shall go for X. I shall not introduce the variable Y. Okay, or in formula you can introduce both X and Y, and whatever required, only that much you can carry, and remaining you can leave it. So write, a student, I'm writing the formula. So I can write BX by BA, BX by BA, this much square. This is also equals to, if you want to write, you can write like this, BY by BC. Even this is also equals to XY by AC. So any of these three may be asked. This is the formula. So this we have written by formula. So the formula is written like this. Now comparing the 1 and 2, what we can write? This left hand side is given. This one is given. And what is required is only this ratio. So this is the required, because this can only, because X can correlate AX and AB. Other cannot correlate this A with X. Getting? So I shall choose this one. You can leave these two parts. So therefore, substitute this. 1 by 2 is equals to BX by AB or BA, their square. This implies BX by AB or BA we can write. For getting this, you have to send the square as the square root. So a square root of 1 by 2. Student, for this square root, that can be even simplified, because 1 is always a perfect square for everything. So this can be simply distributed for numerator and denominator, and we can write 1 by root of 2. Okay, this is the one way. But what we need? But we need AX by AB. So how I can get this AX? Numerator we have this B to X. this b2x, but we need ax. So this ax can be obtained by subtracting bx from ab. See, in denominator we have ab. It is good thing. So if this denominator is subtracted from that numerator, we can get it. So I can apply the componendo, means subtracting 1 on both sides, or take the negative, means 1 minus of this ratio, you will get the same thing. If the sign is coming, we have to adjust those sign. So this is what the conclusion we have to do. Now subtracting 1 from both sides, 1 from both sides. So just go for subtracting. Means I am going to subtract bx by ab minus 1. So while on left hand side we have subtracted 1, right hand side we also need to subtract 1. A student, this numerator become like this. It become bx minus of ab divided by ab is equals to 1 minus of root 2 divided by root 2. Is it okay? Yes, it is okay. Now what is bx minus ab? Observe the figure. Bx, let me rewrite here for your understanding. It is our b, a, c, the x and y is here. Observe, student, it is our bx minus ab. Can we subtract the bigger length ab from the smaller length bx? No, we cannot subtract. So the better thing is you just take the minus outside, that this is minus of ab minus bx. Take this outside, keep this ab as it is. The same thing you can also do on the right hand side, because 1 is smaller, root 2 is bigger. So you may write this as minus of minus 1 plus root 2, or root 2 minus 1 directly. Let me write by root. I can cancel this negative sign. Now we are left with AB. AB is the bigger length. Observe, a student, from this figure I have drawn. AB is our bigger length, this much. From this, we want to subtract the smaller length. Means we have this bigger length BA. From this, we are going to subtract the smaller length BX. So what will left? Only this much will be left. Therefore, I can write AB minus BX as AX. And denominator BA or AB, keep it as it is. And right hand side is our root 2 minus 1 by root 2. So this is the required answer. It's so simple. You may rationalize this, that is also okay. Or AX by AB, because the answer may be given in different form. If there is MCQs, then you may divide it. So root 2 minus 1, you have to distribute this root 2 to both the numerator term, means root 2 as well as for the minus 1. So it is like 1 minus 1 by root 2. It is also okay. Or it may be given that it is in rationalized form. So this may also be given like this: root 2 minus 1 divided by root 2 into root 2. Into root 2 is the rationalizing factor. So multiply this: root 2 into root 2 minus 1 into root 2 divided by root 2 into root 2. So it become like root 2 into root 2 is 2 minus of root 2 divided by 2. So this is the other way of writing. Even These two can be distributed, so this may also be written like this. So go for distributive. So 2 by 2 is 1 and root 2 by 2. So the answer may be given in any of this. 1 minus root 2 by 2 or 2 minus root 2 whole by root 2 or maybe your root 2 minus 1 by root 2. So all the three are correct answer. Even the fourth one is 1 minus 1 by root 2. So these four are the way of writing the answer. This is correct, means root 2 minus 1 by whole root 2, 1 minus root 1 by root 2. Third one is 2 minus root 2 by 2. The fourth one is 1 minus root 2 by 2. So it was all about how to apply this. A student, with all this from my side, I have explained each and everything. Now you have to practice a bit more. So you have to do the homework, the remaining exercise, everything, all the concept I have explained from my side. So do the exercise. What are the exercise left? All the other exercise you may do. Students, it is our 6.4, 6.3 already we have done. You people are not asking the questions. 6.4 and the Pythagoras theorem is your 6.5. You please try this, just adjusting the Pythagoras theorem, you can get it. Say it appear a bit bigger one. If the time permit, next day I will also explain this. Here you have to prove the square as the product of two sides. See this question we have done. Student, the question number 2, 3, all these things I had already explained. Okay, in very beginning of this concept. So 6.4 and 6.5, you please try. Do the 6.4 and 6.5 of our textbook. Please finish this, student. For this triangle, our textbook is very important. So direct questions are asked from the textbook. So please finish it. If you have any doubt, then please ask to me. I will explain. Maybe possible in next day I will solve some of the question for adjusting this. So your homework is also posted. Okay, student, any doubt then please ask, otherwise we shall stop. Already we are running